My name is Amber. I'm from the University of Pretoria. Unfortunately, my partner for research, Vessels, is unable to be here today. He's in Cape Town at the moment, so I'll be presenting for the two of us. And before I start, I'd actually just like to thank Greenovate and Growth Point, their team and their sponsors. You guys have continued to champion the youth of this industry, and we really do appreciate it. We might not we might not say it enough, but we do, and we get very excited for these things. Before we start, I'd just like to make a little bit of a sort of a personal intro, something I was thinking about before I started the presentation. I had a look at the timeline of the climate conferences, and I realized that words like sustainability and environmentally friendly have been circulating since the first climate conference, which was in 1979. Thank you. So why are we where we are after almost 44 years? And what about the next 44? As I was writing about what I wanted to say today, I was reminded by a quote that I actually saw in a net zero case study webinar. And it reads as follows. The first rule of sustainability is to align with natural forces, or at least not try to defy them. So now consider this. The Earth's surface receives more solar energy in a day than we could ever consume in 24 hours. If we could realign our practices to work parallel with natural forces, we can redirect and steward sustainable development of future cities. Before we speak future, where do we stand now? The estimated building stock currently stands at 100 billion buildings, from huts to high-rises. Roughly 75% and up to 80% of carbon emissions and energy use of our built environment is contributed towards buildings. By 2050, it is estimated that 70% of the population will live in urban environments or cities. This is equivalent, which will only occupy about 3% of our land area, which is equivalent to the size of India, more or less. So unfortunately, the odds don't quite look like they're in our favor. This doesn't have to be the narrative forever. Imagine a future where we don't meet environmental standards, we exceed them. We don't try new technologies, we leverage them. We don't retrofit resilience, we engineer it into the fabric of our construction. And we don't have load shedding. Our infrastructure and supply chains are self-sustaining. With new horizons opened by technological innovations such as BIM, a net zero future may not be so distant. The main objective of our research was to investigate how construction and built environment stakeholders can leverage technology in the design phase, emphasis on early on, to streamline net zero certification and eventually reap the economic and environmental benefits of this workflow. Our methodology followed an investigative thematic analysis approach where we keyword search sources and sampled theoretically to ensure flexible discovery yet a nuanced perspective on net zero and BIM. The Green Building Council of South Africa offers net zero certification across 4 categories. Carbon, which references to the operational energy load of buildings. Water, which focuses on operational use as well. Waste, which is generated during construction. And the change in ecological value pre and post development. The focus of the study was to target the categories applicable to new buildings. And this was because optimizing design and material choices early in the project phases are not only cheaper and easier to implement, but are more beneficial and effective for building performance. Now don't be fooled. It may sound simple based off of my last slide, but unfortunately this is the tip of the iceberg. Below the surface lies a multitude of interconnected and integrated relationships and processes. Some of the aspects, this is not all of them, to consider include building performance, passive design strategies, building orientation, daylight analysis, integrated design, complex project teams, site logistics, water harvesting and reuse, sustainable procurement and materials, and then also building massing. Recent research suggested the potential for BIM to be highly and incredibly beneficial for projects pursuing building sustainability assessments or certifications due to the rich diverse data environment that BIM offers. This can now be used to simulate how alternative designs can influence building performance. Designers and engineers have the capability to effectively integrate, oversee, and exchange information across a complex project ecosystem to investigate green buildings in a virtual environment. But before we BIM, we need a team and we need a plan. A BIM project's success or failure depends on this team and this plan. So yes, in this case, if you're failing to plan, you are definitely planning to fail whether you like it or not. The team includes the client, our professional team, which we are already familiar with, and also with new technology comes new job descriptions, like BIM coordinators and BIM managers, which now form integral parts of our project ecosystem. BIM planning should consider project maturity, or what to BIM for. This is defined by three things: the level of information need, which describes the data, geometry, and documentation requirements of stakeholders throughout the project; the model level of development, which refers to the completeness or accuracy of the building model; and the purpose or use case, which is also referred to as BIM dimensions. BIM planning should also consider BIM project delivery, which is defined in project documents such as digital governance documents, such as the ISO and the SANS 19650. It's also defined in your BIM execution plan, which is the process and methodologies implemented for a specific project, and also your digital governance. Traditionally, building sustainability assessment during the design phase is time-consuming and complex, often leading to assessment only in the final construction stages, where changes to buildings meant to improve sustainability performance cost more and are often impractical and infeasible to implement. A Portuguese researcher, José Carvalho, has demonstrated the successful integration of BIM and building sustainability assessment. He was able to simulate 18 different design alternatives and use those results to certify both LEED and BREEAM criteria. Essentially, to implement BIM-based net zero certification, we need to establish workflows. The workflows for digital production of certification data between the model environment and the simulation software, such as integrated environmental solutions, Autodesk Green Building, or Ecotect. To achieve emissions of 0 kilogram CO2 per meter squared per year, it is necessary to model annual consumption and generation of energy sources, both renewable and non-renewable. Operational energy intensity has a strong relationship with architectural passive design strategies, materials and insulation, window-to-wall ratio, glazing type, and the facade design. In order to achieve net zero water consumption of 0 liters per day per meter squared, it is necessary to quantify the on-site renewables, harvesting, recycling, storage, and reuse. Water usage has a relationship with the efficiency of fittings and the collection and reuse strategies. Diverting all construction waste streams from landfill demands a conscientious design approach, prioritizing sustainable alternatives and assessing material reusability, recyclability, and eventually deconstructibility. Material databases and clash detection can enhance waste planning and prevention, while integrating 3D space planning and 4D scheduling in BIM models aids in waste management. For comprehensive waste management, adding 5D quantification techniques to this model can allow for the simultaneous recording of waste volumes as well as costs. To evaluate the change in ecological value of a site, the changes in landscape coverage types must be recorded. The planning, planting, and recording of landscape types can be done within the BIM models. The demarcated areas and plant instance parameters will detail the specifications of this model. From this landscaping layer of your BIM model, the accredited professional can easily access information and advise on design and certification criteria. Successful collaboration in a digital environment like BIM relies heavily on interoperability to support data exchange, enable transdisciplinary collaboration, integrate workflows, and ensure that we future-proof our digital workflows amongst technological change. For transferring information from a BIM model to authoring tools and energy analysis and simulation software, the GB XML file format emerges the most suitable for early design phases. Alternatively, for investigation within the authoring tool, plugins designed by third parties are highly customizable and can be enhanced through application program interfaces or APIs. This allows for project-specific problem solving using optimized methods. However, growing pains are inevitable. The South African industry specifically the South African industry's BIM adoption is specifically hindered by insufficient building design details early on, a lack of internationalized standardization or approaches, interoperability challenges, and difficulties managing fragmented data, as well as competency gaps. We don't have the skills necessary yet here, or at least not in a widespread manner. We have pockets of expertise. So you're probably wondering where QS now fits into all of this. Having come from UV as a QS, I'm talking a lot about green building and a lot about BIM, not so much about the QS perspective yet. The QS is in a unique position as a cost consultant, able to influence design decisions based on financial implications. With the green building market expected to grow to $24.7 trillion by 2030, green building literate quantity surveyors will form key members of our project teams. BIM can assist in efficient, accurate, and structured procurement documentation preparation, which would need to be tailored to net zero specific concerns for each project. This presents an opportunity to expand expertise and drive sustainable design for efficient operation, not only considering the economic bottom line, but making sure that our projects are both socially and environmentally sustainable. In conclusion, by exploring a framework in which net zero certification can be investigated virtually, even from the earliest design phase, the professional team now has the capability to influence design solutions. Teams can also now optimize lifecycle, economic, environmental, and social impact, with the QS in a key position to quantify not only upfront capital costs, but also now realize these savings over the life cycle of a green building. This showcases the influential role in sustainable building the professional teams plays, as consultants can influence developers' decisions based on objective metrics that translate into meaningful and relevant information, used to justify and prove the benefits of green building before ever breaking ground. Thank you.